Today we're going to take a look at graphing quadratics and a couple different methods for doing that. So first we're going to review completing the square, and you guys are getting pretty good at this right now. So we subtract the 4, so negative 4 equals x squared minus 6x plus 4. Oops, I don't know why I had plus 4 there. So our picture, we have x squareds, negative 3x, and that equals negative 4. So we have x and x. So what do we multiply by? We have minus 3 and minus 3. So what's going to go in here? Well, we have to add negative 3 squared to each side. Algebraically, what were we doing this step? Well, we were adding that b over 2 squared to each side. So negative 6 over 2 squared plus negative 6 over 2 squared. So either one, it factors into x minus 3 squared equals 3, 6 over 2 is 3, 9, negative 4, so it equals 5. And now we can take the square root of each side. So we have x minus 3 equals the positive square root of 5, x minus 3 equals negative square root of 5. So we have x equals the square root of 5 plus 3, and x equals negative square root of 5 plus 3. And we have our two answers. Now what we're going to look at today is how to graph these. And a couple key things on our graph. Always remember, if we want to find the y-intercept, that's of the form 0 and some y value. And then we can always find our zeros. We can complete the square factor quadratic formula, and then we can get our vertex by that negative b over 2a. So we know how to do everything today. It's just putting it together. Now there's a couple different forms here. This first one is intercept form. It's much like factored form. So this is an intercept form. It's factored. But if we had a problem like y equals 2x minus 5 times x plus 3, we can't have that 2 here, so we have to factor that out. So we factor out the 2. This becomes x, but right here we factored out a 2. So what we can do is we can put it on the denominator here, divide it by 2, because it's like we pulled one out, which is the same as dividing it by 2, because we're going to divide both of those by 2. And then we have that x plus 3. So similarly, if you have coefficients in both, like 3x minus 4, 4x minus 1, we can't have those coefficients. So this one we divide by 3, this one we divide by 4. So we pulled out a 3, so x minus 4/3. And then this one would be x, we pulled out a 4, and x minus 1/4, and then we can multiply those together. So y equals 12, x minus 4/3, x minus 1/4. We talked about this intercept form the other day, and we've worked quite a bit with standard forms. So now we'll be moving back and forth. So this first question, I'm going to say we're going to graph it, and then we'll find the vertex. So to complete the square, to find those intercepts here, x squared minus 4x minus 5, you can add the 5, and then we have to add that b over 2 squared. So b over 2 squared, 5 plus b over 2 squared. So we end up with, let's see that this is 9, so we have x minus 2 squared. Take the square root of each side. And then we can solve that. So we have x equals 5, x equals negative 1. So those are our intercepts at 1, 1, 2, 3, 4, 5. We can solve this by factoring. If we would have factored this, meaning we have done our box and circle business, we'd end up with the same thing. X squared, negative 4x, negative 5. So a times c is negative 5, so it's got to be negative 5 and 1. We have x and x minus 5 plus 1. So we have x equals 5 and x equals negative 1. The third method we could have done to find those is the quadratic formula and plugging that into this, where you guys can take the time to do that, but I'm pretty confident most of you can plug in those numbers. So no matter what, we'll finish it up on this last one. We have negative 1, 1, 2, 3, 4, 1, 2, 3, 4, 5. Now we have to find our vertex. So x squared minus 4x minus 5. So x equals the opposite of b over 2a. So 4 over 2 equals 2. Plug that in. We got 2 squared minus 4 times 2 minus 5. So 4 minus 8, negative 4 minus 5 is negative 9. So we could graph that 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, somewhere down here. Some of you might notice too, since there's symmetry here, if that equals negative 1 and x equals 5, our vertex is going to be right in the middle of these points. 1, 2, 3, 1, 2, 3. So we know it's going to be 2 because there's that line of symmetry in a parabola. And we can do that because these were at the same y values. Now let's say we wanted to find our y-intercept. Let's plug in 0. 0 squared minus 4x minus 5, or 4 times 0. So our y-intercept is the coordinate 0, negative 5. So 0, 1, 2, 3, 4, 5. So since we know that this is 2 away from our axis of symmetry, there has to be another coordinate that's 2 away at that same height. And now we can draw a very accurate graph. So we have key coordinates here. We have our vertex and our x and y intercepts. So if we take a look at this next one, let's say we have to find the vertex and intercepts. Well, let's see. Let's say you want to, I don't know, you could complete the square. Let's start by finding the vertex, since that's the easiest. So x equals the opposite of b over 2 times 1. So x equals 2. So y equals 2 squared minus 4 times 2 plus 7. So 4 minus 8 is negative 4 plus 7 is 3. So our vertex is the coordinate 2, negative 3. Our y-intercept, that's the easy one. 0 squared plus 4 times 0 plus 7. So it's a coordinate 0, 7. And now for our x-intercepts. This is where we could factor, complete the square, or the quadratic formula. And we didn't do the quadratic formula, so let's do that one. So x equals the opposite of b plus or minus the square root b squared minus 4ac all over 2a. So we have 4 plus or minus the square root 16 minus 28, negative 12, all over 2. So if it's a negative, we know this is imaginary and it doesn't cross the x-axis. So for the second one, let's see if we can find the vertex. X equals the opposite of b over 2 times negative 2. So we have negative 3. So y equals negative 2 times negative 3 squared, 12 times negative 3, minus 23. Let's see, 9, negative 18, right? 9, negative 18 plus 36 minus 23. So 18 minus 23 is negative 5. So our vertex is negative 3, negative 5. Our y-intercept, plug in 0, so negative 2 times 0 squared, 12 times 0 minus 23. So it's at coordinate 0, negative 23. And then we could try the quadratic formula, complete the square. Let's try, and I'll leave that up to you guys. Any method to find the x-intercepts. And usually if it looks like a messy one, I usually jump to the quadratic formula, but this one might not be bad for completing the square, except you see that this would be a fraction if you divided everything by negative 2. So then I wouldn't do that one. So I'd try factoring or the quadratic formula. So let's say you have to graph this. Oops, we need to add a square there. So key points, we have those intercepts. So we have negative 1, 2, 3, 4, 5. Oops. Yep. 1, 2, 3, 4, 5. We have to find that vertex. Well, it's not in vertex form, so we know it's right in the middle, and we can't do negative b over 2a. So 1, 2, 3, 1, 2, 3, 4, 5, 6. So it's 1, 2, 3. So here's the vertex is somewhere along here where x equals 2. So we can do 1/2, 2 plus 1 times 2 minus 5. So let's see, 2 plus 1 is 3 times negative 3 and 1/2. So 3 times negative 3 is 9, negative 4.5. So 1, 2, 3, 1, 2, 3, 4.5 right here. And then we could easily find the y-intercept. 1/2, 0 plus 1, 0 minus 5. So half times 1 times negative 5, so negative 2.5. And we could add a point, because it's 2 over, so here's another one. So here's that first parabola. The second one, well, it's in vertex form. So our vertex is negative 2 and 1. We know it's going to be downward facing. Well, let's see. What is our y-intercept? What's negative 2 times 0 plus 2 squared plus 1? So negative 2 times 2 squared plus 1. So we got negative 8 plus 1, negative 7. 1, 2, 3, 4, 5, 6, 7. This is our axis of symmetry, so it's 2 away. So here's another one. To find our y-intercepts, our x-intercepts, we'd have to do some multiplying out. So we have x plus 2 times x plus 2 plus 1. So we'd have to distribute and multiply this out. But as long as you have 3 good coordinates that you can label on your graph, you should be all right. But one of them should always be that vertex.